Okay, yet another very simple question, very basic question. The diagram below shows the change in the states of water. Alright, so we know that there are three states of water. Let's revise. Okay, we have solids. Okay, wait, let me write it here. Okay, let's look. The solids. Okay, solids have definite shape. Okay, definite shape and definite volume. Okay, that means it is examples would be like metal in room temperature, ice, we have wood at room temperature, and so on and so forth. So solids have definite shape and definite volume. Then we have liquids. Yeah, liquids have a definite volume. That means they can't be compressed. Okay, but they have no definite shape. That's why you can pour a liquid from one container to the other. Okay, and it would fill up a container because uh, it can be poured from one container to the other, from a mug to a cup, and so on and so forth, because it has no definite shape. Okay, and but it does have a definite volume, meaning it can't be compressed. And then we have gases. Okay, gases have no definite shape, right? And it has no definite volume, right? And that's the reason is because just like liquid, gases can be, you know, in of any shape. It actually follows the shape of the container that it is in. And so if you change the container, it will change its shape according to the container that you are using. All right, so but gases has no definite volume. That means gases can be compressed. Okay, like I've said, a room full, a room full of air. The amount of air in a room can actually be compressed into an oxygen tank, for example. Okay, which is much smaller, with a different shape altogether. Because gases has no definite volume. It can be compressed if you have a force strong enough to compress it. Okay, so with that, we have here three options. So this is obviously a solid. Okay, this is obviously a solid. So I'm going to delete this. Okay, no definite shape, no definite volume. We know that this is a solid. Okay, no definite shape but a definite volume. We know that this is a liquid. And then we have a definite shape. Oh, sorry, my bad. I got it the other way around. Okay, no definite shape, no definite volume is gas. Oops, it's gas. Very hard to write and type at the same time. So no definite shape, no definite volume is gas. All right, then we have no definite shape but definite volume, and we have what state would this be? This would be liquid. Okay, so I can change it like that. And then we have no we have a definite shape and a definite volume. So a definite shape and a definite volume is definitely solid, right? So we have all the three states here. Okay, now this is where the heat energy comes in. Okay, we know that for gas to become a liquid, all right, is also known as condensation. And we know that condensation, so W is actually condensation. I'm going to write that down. Condensation. And we know that condensation is actually a process that requires heat loss. Right, so if it's water vapor here, it needs to lose heat in order to condense. Okay, now from liquid to gas, we know that as evaporation. So yeah, I'm going to write down here evaporation. And we know that evaporation requires the opposite of heat loss, which is heat gain, right? So there is a gain of heat here, okay? Right. Okay, now, so from gas to liquid, we know it as gas to liquid condensation, liquid to gas evaporation, heat loss in order to become a liquid, heat gain in order to become a gas. If we look at the other side, we have X. X is from liquid to solid, putting water in a freezer to get ice. We call that freezing. All right, and freezing requires heat loss. All right, why? That's why you put the water in the freezer because it's much cooler there, so that the heat in the water can be absorbed by the cooler environment. So when water loses heat in the freezer, it becomes ice. And from solid to liquid, we call that melting, just like ice melts when it gains heat, right? So if you want ice to melt, you put it in a warmer environment. Okay, so if you can see the uh, pattern here, right, you will see that uh, from gas to liquid heat loss, liquid to solid heat loss, solid to liquid heat gain, liquid gas heat gain. So there is actually a pattern, but the names of the processes are different. Okay, but you really need to know this. This is the basic of heat loss and heat gain of the three states of matter, and this very important relationship between the state of the matter and between the transfer of heat energy is something that you really need to know, really need to understand and apply in different situations. So even though this is a very basic question, it is actually very good revision, and you really need to spend a lot of time understanding these concepts if you don't already know so. Okay, so thank you very much. Do not be shy to stop and to replay the video so that you can understand all the concepts covered here better. Thank you.